Okay, in this question, they give us a function. Let me bring it down here. S of t equals 6 cosine t. I make my t a capital, so it doesn't look like a plus sign. So anyway, this is in centimeters. Centimeters. T is in seconds, it says. Okay, and they want what? They want the rate at which the spring is oscillating. The rate. So a rate is a derivative or a slope. So to find the rate, we find the derivative. So that's how fast something's happening. Why? How do I know that? Well, because remember what a slope is. A slope is rise over run. And rise is y, run is x. It's how fast something's rising over how fast it's running. What is y in this case? Y is the function, which is s, which is centimeters. And what is run? Run is always x. What x is t in this case, seconds. That'll give me centimeters per second. See how I'm coming up with that? Slope, is rise over run. Rise is y. Y is the original function. Y values are the original function, which is centimeters. And the t is like the x, which is seconds. Centimeters per second. That's a rate. Like I said, that caterpillar was moving along the table at 10 centimeters per second. That's how fast something's moving. So a rate is a slope, is a derivative. Remember, derivatives are slopes, instantaneous slopes, slopes at only one point. So when they ask you rate in a question in math and science, you think, oh, it's slope, it's derivative. I got to take the derivative. So I'm going to come down here and go, okay, I need S prime. I need the derivative to find the slope or the rate. So what's the derivative of 6 cosine? Derivative of cosine is negative sine. The 6 just sits in the front. And they said at t equals 8 seconds. So now I'm going to plug in an 8 right there. So let's do that. And so this will become 6 times negative sine of 8. And let's go to the Desmos calculator. Okay, this is 6 times negative sine of 8. Enter. Now you got to make sure. See, there's degree, radian. Make sure you're in radian mode because that 8 must be radian. How do we know it's radians? It's automatically radians when we do trig functions in calculus, unless they specifically say degrees. So that 8 must be radians. And so there we go. It's negative 5.9361. Let's go back. So that's not coming out right. So what are we doing wrong? Seconds. T is 8 seconds. So we plug that in. The S prime, derivative of cosine, is negative sine of 8. And they're saying negative 5.936. Let's go back. Centimeters per second, negative 5.936. Negative. Oh, no, that is right. I'm sorry. There it is. That's right. Negative 5.93. I don't know why I thought it was wrong. It's right. We got it. And there it is.